Okay, we'll look at page 5, naming compounds. These are some excellent Tyler DeWitt videos as well here, and it tells you what time. By the time you see your copy of this, I'll have my time filled in here. And by the way, all my recordings are just under 15 minutes, so YouTube likes it that way. Okay, so now that we've written formulas of compounds, we have to saddle up a little bigger horse. By that I mean these are going to be a little bit more challenging. We can't get bucked off here though. So, and I put number 1 on here just because it's hard to it's hard to see. We know we have a positive and negative ion here, but this is what I left off with last time, talking about ammonium, which is the positive ion here, is the NH4. So that's my positive ion, my +1, and fluoride here is my negative ion. So we know we always have a plus and a minus. This NH4 is ammonium, and my negative is fluoride. Now please take your time to spell these out correctly. Alright, so we're going to just do some of these here. Again, these are great Tyler DeWitt videos, and I will get you started with this. So if we have Hg, here's how I would attack these. Hg, mercury. Then you might look at your pink sheet, or maybe you remember mercury. Oh, we need Roman numerals. If you're not sure if you need Roman numerals, if it has Roman numerals here, so mercury has Roman numerals, but this one's going to be easy because mercury 1 always has to have a 2 here. So there is no 2 in this one down below at all, so we know we don't have mercury 1. This has to be mercury 2, and I'm going to put it in right now. And now that we had those mercury compounds together, let me point out something as well. So, the old way to do it was to use these prefixes ic and us. So mercuric is the same as mercury 2, mercurous is the same as mercury 1. So I left the old way to do it on there as well. Okay. Well, we know we have mercury 2, and this Cl has to be negative, written to the right. This mercury 2 chloride. Number 3, we have K. Now K, potassium. You might have to scan your sheet here to find this, but potassium here, K. Now, do we need Roman numerals for potassium? And the answer to that is no. And the reason we don't need Roman numerals is the only positive oxidation state it takes on is +1. So if it's always +1, we're never going to use Roman numerals for it. The same way with calcium is always +2. We're never going to use Roman numerals for that. Scandium is always +3. We're never going to use Roman numerals for that. But when we get to something like titanium, we're going to have to use Roman numerals because it has 3 possibilities. Zirconium only has 1. So, if there's more than one positive charge here, or if you see the parentheses on your pink sheet, we need Roman numerals. Potassium is always, always, always +1, so we just have potassium bromide. Number 4, same way. Ag is silver. Even though silver, I should point out, is a transition element here in the middle, it only has 1 possible charge. So silver, and the I is iodine, so we have silver iodine. Okay, in number 5, we have sodium is our positive, the next one for our negative is a polyatomic ion is this C2H3O2. This, we know we have sodium. C2H3O2 normally, because you have to find these. For example, if I drop down to number 6, we need to look for this polyatomic ion. You're going to look under the C's alphabetically on your pink sheet to find it normally. You would think you could look under the C's here, but this letter tells you where to look. This letter here helps you find the C2H3O2. Otherwise, you have to scan and scan and scan to find C2H3O2, and there's the left column, and there's the middle column, and there is the right column, and you would never think in a million years to look for the very first one, right? So it would drive you nuts looking for it. So there are a couple ways to write acetate. I will use C2H3O2, and it's a -1. So this right here, we have sodium. We don't need Roman numerals. The C2H3O2 is acetate, so we have sodium acetate. Number 6, Mn is manganese. And we for sure need Roman numerals, so we'll come back to this. And now you'd look under the C's for this. So if we scan our sheet, we need to scan until we find ClO3, and Cl is chlorate. So the name of that ion is chlorate, and it's -1. So remember, it's -1. We'll write down the chlorate. But now we need to figure out what that charge is of our manganese. And we can do the same thing we did previously. I'm going to move to the right, and we have Mn. We have ClO3, ClO3. If we take away the parentheses, we said that chlorate is -1, -1. So the manganese is +2. That gets us 0 across the top. So that is manganese 2 chlorate. Okay, we'll do a couple more here, and then we'll let you finish these. Bi bismuth. And if you don't know it's bismuth, of course, you're going to scan till you find it, and you'll naturally memorize these. A substantial number of these you will memorize. So we have bismuth, and we can look here on our pink sheet, and bismuth can be a 3 or a 5, so we know we need Roman numerals. And it wouldn't hurt to put a +3 +5. You know that's what you got to get for an answer. So it wouldn't hurt to put it up there. You know, manganese is 2, 3, 4, 6, 7. I mean, you could go 2, 3, 4, 6, 7. And that would help you out. You know for sure that Roman numeral has to be one of those. So PTCl6 is not under the P's. You're going to find it alphabetically H. And you will find PTCl6 as hexachloroplatinate with a -2 charge. Okay, it's not that difficult. Hexa means 6. Chloro is that chlorine right there, and platinate is the PT, the platinum. So hexachloroplatinate. You could sound that out. So we need to write that in as hexa chloro. I want to make sure I spell this let you write that in. The hexachloroplatinate was -2. So if hexachloroplatinate is -2, then if you have 5 of them, that gives you -10. That means our bismuth is the +5, right? So we have bismuth 5. Okay, we'll do a couple more here, and then we will turn you loose. Let's do number 18. So S is sulfur. We for sure need Roman numerals, and sulfur can be 2, 4, or 6. We could find it here on our sheet. 2, 4, 6, and maybe we want to put this down. We know we've got to have 2, 4, 6 in our Roman numerals. Now O2 in parentheses is automatic, peroxide. So O2 in parentheses automatically peroxide. Peroxide is -2, and you have 3 of them. That gives you -6, right? And you could expand it out and say, well, we have O2, O2, O2. That would be the same. But if that's a -6, we know that we have a sulfur 6. -2, -2, -2. We have a sulfur 6 to get 0, right? Sulfur 6. What's another one? Let's see. Let's look at 25. 31's another one. But if you look at 25, and here's a good lesson in 25. If you look up chromium can be 2, 3, or 6. Oops, get over here. 2, 3, 6. So I'm going to put this for the 25. I know chromium can be 2, 3, 6. Now, when I look at 25, I go, this will be easy. You got chromium, and we've got an oxide, and oxide always is -2, -2. So I have chromium 4 oxide. That's what I would think when I first did this. But that's wrong, because there is no chromium 4. Now, when you have O2 in parentheses, like the previous example that we did here, this is a dead giveaway that that is peroxide. But without parentheses, it still could be peroxide. And in this case, it is. I have the P there to tell us that. So if you treat that as a peroxide, you would go O2 -2 together. Chromium has to be 2. And that gets us 0, right? And that works. There's our 2. Match. So this one right here is not chromium 4 oxide. It is chromium Roman numeral 2 peroxide. Okay, finish this page through page 6, and we'll get another recording out.